Okay, welcome to the second video for this tutorial series. Here we'll be creating a demo project or the Hello World project for microcontrollers. So here we'll start with a new project in Proteus. So I'll just click new project and I'll browse to my previous location. Here is that folder. So I'm going to call this linking layer project. Linking layer like that. So choose the F4 and then continue, next, finish. So I have that as a linking layer thing, project. So what I'll do is I'll go to component mode. We're going to place the PIC 16 877A. That's the one I want to use. Simply double click and it will show up here. Then we'll need a resistor. Just choose a generic resistor. Then we'll need a capacitor. Let's go for the generic capacitor. Then we'll need a crystal. And I'll go for that one. Quartz crystal. And then what else do we need? I think those are enough. So click OK. First of all, place the microcontroller there. And then we'll get I'll put the crystal next. I'll just place it over here. Then some capacitors. I'll put the capacitor here. Rotate it to face upwards and then put the capacitor again here. Another one, rotate it. So we need two capacitors. Okay, so with our capacitors placed, what we're going to do is to connect them and then ground them. So connect the ceramic crystal like this to the two capacitors. And then also make a connection to the microcontroller, in and then out like that. So we need a ground, so we go to terminals and then place our ground over here. So I'll connect it to that. Now our crystal has been connected, so go back to component mode. We're going to select a resistor, place it over here. We also need, I actually forgot a diode, so I'll just type diode here. And oh no, actually what I need is an LED, so just LED. We can take the animated one, generic light emitting diode. Alternatively, I can take this one, LED blue. It's also animated, so just double click on that and yeah. So we place our LED over here, connect the cathode to the resistor like that, and the LED to any port you want, in this case RB0. Okay, so we're going to need ground again, so that we connect the LED to the ground. So in this way it will be turned on when this pin is high. Okay, yeah. So that should do it. Okay, so now we make a few set changes here. The capacitor, we should use 22 nanofarad should do it. Same for this one, capacitor 2. I'll just change the value to 22. Okay. So for our resistor, we call this a pull-up resistor. So we change the resistance to 330. Yeah, so if you look at the voltage division thing, you should be able to compute that resistance. So the amount is going to be 330 for LEDs in general. So let's click OK. And yeah, so this LEDs will be turned on when the pin is active, since we've grounded it over here. So now let's go over to I'll just save this one up. Then let's go over to mikroC Pro. So here I'm going to click new project, and yeah, just standard project. Next. So browse a folder where I'm going to save it. I'll put it in the same folder as our Proteus file. So this is over here. So inside microcontroller circuits, so I'll just click OK, and I'll give it the same name. I'll call it blinking LED. So click next. We must select a device. Of course, I forgot to select the device. So we need PIC 16F. The device is supposed to match the microcontroller we have in Proteus. So 16F is this is 16C, 16F877A, somewhere down here. The list is quite long, so 16F, not this one. Somewhere here, that's the one. Device clock, I'll just leave that one, so continue. And file, let's just finish. We'll add the file later. Okay, so that is our file. It should say blinking LED.c. Okay, so there's a pop-up window here that usually shows up whenever you create a new project, and if a C file opens up, it should prompt you to save that C file. So just save it in that same directory, and you don't have to change the name. So this is a C file, so save it. So we have a project file. Our project file is blinking LED.mccpi, and then the C file is actually the one we're most interested in. Yeah, so by default, this is what we have as our program. So this is the main program. Okay, so within our main program, we have basically two parts. We have the initialization, like that, initialization. We have the initialization routines, and we also have the main program logic. So we have those two parts. So also we can have preprocessor directives outside here. Outside the main function. So for those of you who are not familiar with the C language, I recommend that you should visit this. Let's go to W3 schools, just Google that and then check out C, and then try out the tutorials here for C, from getting started up to pointers, and then also cover functions. So these two parts are what you need. The intro and functions. Okay, so make sure you're well conversant with that before you look at microcontroller circuits. Otherwise, things are going to get very hard for you. Okay, so for this kind of blinking LED, preprocessor directive, I don't have to put anything, but under initialization routines, we put a code, we put trace bf, trace b.f 0, so 0 like that, and then this is equal to 0. So this means we are setting the port RB0 as our output. Okay, setting port RB0 as output. So that is our initialization. So for our main program logic, that is where we have the while one loop. Okay, for those of you who are familiar with that, we will always be having the while one loop. For while one, do something, you'll be doing something in the, so you have that loop. So that, yeah, alright, so this is our main program logic. I was just able to finish it up without recording. Now I'll just explain what this bus mean. So port BF0, this is, we are setting that pin to 1. It means it is active when high. So that is active high. So the delay, we have a delay function, delay for half a second. Okay, just delay for half a second, and then this one means turn off the port. Okay, so turn off the port. It's just just say turn off. Turn off. You can say RB0. That one, and then another delay for half a second again. Okay, so here you activate the port by sending a 1, then wait. So it means the LED is going to stay active for half a second, then you turn off. It will stay turned off for another half a second. So when you're done with that, just click build. So if you don't get any errors, the errors are usually in red. If you see some red things here, it shows that you've gotten an error. Yeah, but since we don't have any errors, so everything is okay. Also make sure the clock frequency, this is the same as one you'll be using in Proteus. So we go over to Proteus. Okay, so I'll build it again, and then okay, just head over to Proteus. So this is our RB0 where the resistor is connected. Simply double click on this, and also here make sure the clock frequency is the same as what you have in your program. So we'll click this to browse for that file, and it should be in the same directory. So we are looking for a hex file. When you click build, it creates a hex file. So just double click on it and then click OK. Yeah. Okay, so now that we have everything set up, just hit the play button. You see the LED turning off and on and off every after a second. to turn on and stay on for a second, and then stay off for another second in that sequence. Alright, so yeah, in case you're having trouble with navigating this mikroC Pro, you can go to the help by simply clicking F1, then look for PIC language reference. So this will teach you everything you need to know to get you started. That is if you are done with this. If you've gone through this, you can go right ahead and check this out. It's the same. These are just tutorial for this one. This is specific for embedded C for PIC microcontrollers. So you can go through these and you get to know how to use them in embedded C. And if you're done with that, if you're looking for something specific or a specific library, you can just come here, pick libraries, and check out the firmware for the libraries, and you see how to include specific libraries and then what to do when the library has been included. Okay, so that's it for now. Meet in the next video.